All right, let's toss it over to Melinda Kernik, and she's going to talk about building a geospatial data curation toolkit.
All right. Hello, everyone. My name is Melinda Kernik. I'm part of the Big 10 GeoPortal project, as well as a spatial data curator for the data repository at the University of Minnesota. I just finished a 6-week professional development leave last Friday. And for the project, I created a set of tools which help with checking, transforming, and documenting spatial data. The tools are built in Python, but are designed so that you shouldn't need to know Python in order to use them. So today I'm going to talk briefly about the tools through the lens of the challenges that they are meant to address. So first up, transforming geodatabases into shapefiles. Geodatabases are popular among GIS researchers, but it is a proprietary file format. And because of this, it is common practice to transform feature classes into shapefiles when archiving or sharing data publicly. Shapefiles are accepted by a large number of platforms, but they also have some substantial limitations that can lead to loss of data and functionality during conversion. You have probably seen the cut-off garbled mess that can result from the 10-character limit on field names. And there's also length limitations on text fields, on date fields, on the total number of fields, and many other things. ArcGIS will not warn you if it's going to alter, truncate, or completely remove fields as it transforms a layer. So it can be really hard to tell if things got messed up, even if it successfully completed the action. So Esri will not warn you, so I've created a custom ArcGIS tool that will. So when you open the tool, you can select one or multiple geodatabases, and then the resulting report has a section on the top that will provide information and warnings about the geodatabase as a whole. Each valid feature class has a section in the report below with a summary of possible warnings and then details about any issues that were found. So in this example, the only warning is for long field names. And then in the details section, it will tell you what the truncated names will look like, and it will give you an extra warning if multiple fields are going to have the same name after they're truncated. So it can help you decide whether you need to take additional action before converting or look into different file format options. All right, challenge number 2. As a curator, often the spatial data I receive are part of a larger research project. So for example, there might be a shapefile with locations where water quality samples were collected, but most of the research is actually the chemical analysis of those samples. And so in situations like this, spatial data doesn't stand on its own. It's not a good fit for a geoportal. Also, the researchers and folks reusing the data may not be familiar with standard geospatial metadata or the tools that can read them. So really what's needed is simple, human readable documentation that can be easily combined with information about data in other formats. So I've written a couple of tools that will create file and field lists, one for geodatabases and one that works for a directory of shapefiles. And these tools are most useful if there isn't already existing metadata. The resulting lists can be sent back to researchers, making it easier for them to document what the different files and the different fields are in their work. It can also help you get a sense of complex data sets without having to open every layer individually. So the geodatabase inventory tool has the added feature that it will list attribute domains and subtypes if they have been defined. And the shapefile inventory tool runs in an open source environment. And in addition to the file list that is similar to what was in the last slide, it also looks for missing file extensions and checks whether shapefiles are in the folder are using the same projection. All of the tools are available through GitHub. So you can download them by going to code and then download zip. There's information about how to use the different tools in the folder, as well as more description of what the tools do. There's also a sample report, so you can, oh, that didn't work. There's a sample report so that you can see sort of what is going on and what you're going to get as an output before you start messing around with the tools. All of these are available with a Creative Commons license, so feel free to use, share, and make derivatives. And then finally, I finished this last week. This is my first GitHub repo, so I would love your feedback. Please, if you see any errors, make an issue. There is a discussion board if you have any suggestions or questions. And if GitHub isn't your thing, feel free to just email me directly. Yeah, hope the toolkit is helpful, and thanks for listening.